Good day, folks. Welcome to my YouTube channel. Guys, thank you for your support. Please continue to like all my videos and watch all my videos till the end and share with your families and friends. Download the videos. Thank you. Guys, this is Newton's second law. It's a system. It's June 2023. It's a national paper. Let's cut the chase. The block A of mass of M is connected with block B with mass of 7.5 by light intensible string or rope passing over a frictionless pulley. Block B is initially held. So that means if it's initially held, that means its initial velocity here is 0, and above 1.5 meters above the ground, while the block A is initially stationary on the ground. So both blocks initially they are stationary, so their initial velocities is 0. Okay, now it says at the bottom, when block B is released, it moves vertically downwards, strikes the ground with the velocity of 3.41 meters per second. So this simply means that this system is accelerating this way, right? So while it accelerates that way, this block it moves it moves from there at the top to the bottom to here. So when it reaches the ground, we are told this is block B. It arrives here with the final velocity that is 3.41 meters per second. Right? What do you need to remember, guys? As this block moves down, its velocity increases. The same velocity that it moves by, the increment of the velocity is the same velocity that this one moves by. So if here the velocity is 1 meters per second, and somewhere where this block is here, while it's moving up, it's 1 meters per second. So what do you need to note about the system, guys? The acceleration and the velocity and the tension are the same, but the tension are the same but in opposite direction. I'll tell you about that. So what I mean about the acceleration, this accelerates upwards and this one accelerates downwards with the same acceleration, same amount or same magnitude of acceleration. And this block has a tension force that is going upwards, and this one also has a tension force that is going upwards, and that tension force is the same but in opposite direction. Right? Okay. Now since it's moving in this direction, we'll choose that direction as what? As positive. When we choose that direction as positive, we mean in this side of block A, the tension force is going up and it's going to be positive, and the gravitational force is going down and it's going to be negative. That's what we mean. And then when we go to block B down is positive. So we mean the gravitational force will be positive and the tension force will be negative. That's how you choose the direction on the system. Guys, they have the same velocity, same acceleration. Now, it says ignore the effect of friction. Guys, if we did not ignore the effect of friction here, we were going to have the air resistance that resists the two objects from moving, that opposes the motion. Now, guys, it says in 2.1, show by means of a calculation that the magnitude of acceleration of block B is 3.88 meters per second square while the block is moving vertically upwards. Guys, as I've mentioned here, we have the initial velocity and the final velocity, and the displacement of block B is 1.5, and the 1.5 is positive because it's moving downwards. Remember, in this side of block B we said down is positive, and even this final velocity is positive as well. So in 2.1, what do we have? We have the initial velocity, we have the final velocity. It's 3.41 meters per second, and we wanted the acceleration. And do we have time? We do not have. We do not have time, so we want to prove the acceleration. So we'll use the formula that says v squared is equal to v initial squared plus 2a change in y, and then we substitute. What is our final velocity? Is 3.41 square equal to initial velocity is 0 plus 2a. The acceleration is the one that we want to prove, and our displacement is 1.5, right? So here we're going to have 3. It's 2 times 1.5. It's going to be 3a, and then we have a 3.41 square, and then we divide by 3. We divide by 3 both sides. So our acceleration here, it will be exactly what is needed there. It will be 3.88 meters per second square. So it simply means that block B accelerates by 3.88 upwards, and block B accelerate by 3.88 downwards, right? Now in 2.2 it says draw a free body diagram, label a free body diagram, all the forces acting on B immediately after it's released. So guys, it's very important, the free body diagram. So we'll represent the block B by a dot, and then block B, it accelerates downwards, so that means the gravitational force that is moving the object downwards is going to be greater than the tension force. This is block B. Guys, I would like to do for block A as well, even though we are not asked for block A. For block A here, we have a what? Block A is going upward, and the upward force is the tension force. The tension force is going to be bigger, and the gravitational force is going to be smaller, right? Now in 2.3 it says state Newton's second law. Guys, it's very important to know the law by heart. It says when a resultant or a net force acts on an object, the object will accelerate in the direction of the force with an acceleration that is directly proportional to the force and inversely proportional to the mass of an object. You need to know it by heart according to the exam guideline. Now let's go to 2.4. 2.4 it says, in 2.4 it says calculate the value m by applying Newton's second law to each block while it's moving. So by saying calculate the value m, they mean the mass of block A. We do not have the mass of that, we are only given the mass of block B. And by saying using Newton's second law to each, that means we're going to use the simultaneous equation and apply the Newton's second law on each equation. So we'll start with block A. I'll say A is equal to F net equal to MA. You see, I'm labeling that I'm dealing with the block block A. Now in block A, what are the forces that are acting in block A? In block A, here is it. You see how important to have the free body diagram. In block A, I have a tension force, and in block A, remember I said upward is positive and downward is negative. So the tension force here will be what? Positive. So we'll have the positive tension force minus the gravitational force is equal to MA. Now tension force is equal to the FG is going to be mg. The mass there, it's the one that we do not know, and the acceleration is 9.8. Guys, be careful here, it's mg, so it's a gravitational acceleration, right? It's the gravitational acceleration there. So it's very important to put the 9.8 there. So equal to the mass we do not know, and the acceleration, our acceleration here is we said up is positive. Our acceleration, it's 3.88. Acceleration is 3.88 there. So what are we going to have? We're going to have 9.8 m is equal to 3.88 m. So we're going to have t is equal to 3.88 plus 3.88 plus the 3.88 plus that, we're going to have 3.88 m plus 9.8 m, which is when we punch that in the calculator, where's my calculator now? Okay, 3.88 plus 9.8, it gives us the T is equal to 13.68 m. We'll make that as equation 1. So now we go to equation 2. The equation 2, it will be for block B, where we are given the mass, said F net is equal to MA. So now in block B, guys, we said up is negative and down is positive. So we're going to have there Fg, that is positive, minus the tension force is equal to Ma. What do you need to take note of? The tension force are going in opposite direction all the time. It's very important that. So our Fg, it's going to be 7.5 times 9.8. The 7.5 times 9.8, let me punch quickly that in the calculator. 7.5 times 9.8, it's minus T is equal to our mass at 7.5 times at 3,88. So 7.5, which is, what is 7.5 there? The 7.5 is the mass times the gravity. It's going to be 73,5 minus T equal to another 7.5 times 3,88. It will be 29,1. So what are we going to have now? We're going to have we'll take the T to that side. If we take the T to that side, we'll have 73,5 minus 29,1. So our T here, it will be 73,5 minus 29,1. Our tension force is 44,4 newtons. That's equation 2. So now we have these two equations now, this 1 and 2. So it's best to substitute this here. So what we're going to have now, we're going to substitute equation 2 into equation 1. So we'll say here we'll substitute the 44,4 equal to 13,68 m, and then we divide by 13,68 both sides. So our mass will be 44,4 divided by 13,68. Our mass here will be 3,25 kg. That's the mass. That's the mass of block A. Right. The 2.5, it says calculate the maximum height above the ground reached by block A. Now guys, when block A moves upward, so we want its maximum height when block B reaches the ground. So when block B reaches the ground, we want the height where will be block A above the ground. But what is important here, what you need to note, guys, when block B reaches the ground, block A will be 1.5. Block B travel the displacement of 1.5 to the ground. So when block B reaches the ground, block A will be 1.5 above the ground as well, because they're traveling the same distance. Will be 1.5 above the ground, but block A, it continues, right? It continues upwards. Now block B reaches the ground by the velocity of 3,41 meters per second, and then block A where it will be above the ground. When block B reaches the ground, it will have the velocity of 3,41, same velocity. As I've mentioned that they're traveling with the same velocity, it will have the same velocity, but it still continues, right? It's still, so it doesn't end here. The block A doesn't end here when block B reaches the ground. It continues, right? But it continues without the tension force now. So it's just moving by itself upwards. It's a projectile. It's going to be a projectile in that case. So now let's say when block B reaches, block A reaches this point. Let's say this is block A. Its velocity, which is it's an initial, it's going to be 3,41 meters per second, and it continues, right? Because it continues as a free fall. This is block A. It continues, but when it continues and reach the final velocity of 0, it will stop. It will continue moving and it will stop, and its height above the ground there, it's going to be 1.5, same height as this one. So what are we going to do now? We're going to calculate its the height that it has traveled from 1.5. We wanted this height, we wanted this distance. So the height that we know, it's 1.5, but we want to know the height from here to here, and then we'll add the two. It will tell us what is the maximum height. So we'll first calculate that height there. We'll calculate that height. This is 2.5. 2.5. What do we have there? We have the final velocity. We know from 1.5 above, its final velocity will 0. Eventually it will stop, and then its initial velocity, it will be the velocity 3.41. It will be the velocity of block B when it reaches the ground, right? And now, since it's a free fall, it operates, the only force that acts on it is the gravitational force. So our G, we chose up as positive at block A, if you still remember. This side up is what is positive. So our G is going to be negative 9.8 here in this side. So it will be negative 9.8 meters per second, and we want the displacement. It's going up, and we do not have time, so we avoided the equation that has time. So we use this equation: v squared is equal to v initial plus 2a change in y. So our final velocity is 0. Initial velocity, it's 3,41 squared plus 2. The acceleration, it's 9.8. We want this displacement. So what we're going to have, it's going to be negative 3,41 squared equal to negative 19.6 times change in y, and then we divide by negative 19.6 and negative 19.6 both sides. If you punch that in the calculator, you get the displacement that is 0.59 meters, right? 0.59 meters. What is 0.59 meters? It's this height, it's this displacement. When it reaches here, it's traveled this distance there. Let me draw it again, guys. Let me draw it again. So we have block A here and block B here. Now when block B reaches the ground, it reaches with the velocity of 3.41 meters per second, and it travels this distance, that is 1.5 meters. So when it reaches the ground, same as block A will be 1.5 meters above the ground, block A. And while block B reaches with the velocity of 3.41 meters per second, even block A will have the same velocity, 3.41, right? But block A continues. let's say block A, it will stop here because this one, it has stopped, it has to stop, but it stopped after. So block A, so we know when it's here, it's 1.5 above the ground, so we want this displacement from here to here. So I use this, I've taken this as an initial, and then when it gets there, it will stop. The final velocity will be 0. We want this displacement. That's what we've done. So we have calculated this displacement. Here is it, right? So, and we use 9.8 as an acceleration, not that 3,88 meters per second, because now it moves upwards as a projectile or a free fall. There's no other force that is acting on it. Even the tension force is not acting on it, because this one was pulling it. It's already down. It's no longer pulling it. So now what are we going to do? We'll do the maximum height now. The maximum height above the ground, it's this 1.5 plus this 0. So we'll say 1.5 plus 0.59. So the answer will be 2,09 meters above the ground.